So in section 5.4, our objectives are to recognize the difference of squares, and then to factor the difference of squares, to recognize a perfect square trinomial, and then to factor perfect square trinomials. So you may recall that we, at one point, when we were factoring, when we were multiplying binomials out, we had things like x plus 2 and x minus 2. And there was a formula for doing that I told you could learn or not learn, and that it was fine either way. But when we multiplied those out, we noticed that the outer terms and the inner terms canceled each other out. They were opposites of each other. And we ended up with the square of the first term, x squared, minus the square of the second term, minus 4. And this result that we got here was called the difference of squares. Difference because it's subtraction, and squares because each of these is a perfect square. Now when we're factoring, we go backwards, don't we, from the trinomial, or in this case it's going to be a binomial, to the two binomial factors that gave us that. And this is something that you're going to have to learn to recognize. You're going to have to learn to recognize the difference of squares. So if you have something like y squared minus 16, this is the difference of squares, and the way you recognize that is that the first term is a perfect square, the last term is a perfect square, and it's subtraction between them, difference. And when we have difference of squares, this is how it factors. The square root of the first plus the square root of the second, and the square root of the first minus the square root of the second. If we put that in our mathy terms, it would look like this. A squared minus b squared factors to a plus b, a minus b. And this particular formula is very important to remember. Whenever you see a binomial that is the difference of squares, you need to be able to recognize it first of all as the difference of squares. And then you also need to be able to factor it as the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So what if we had something like 4a squared minus 9? It's got two terms and a subtraction sign between them. That means we're going to look to see if it is the difference of squares. So we look at this first term here. We look at the 4a squared. Is that a perfect square? Well, 4, the number, is a perfect square. It's 2 times 2. And a squared is a perfect square. It's a times a. So that first one, yes, it is a perfect square. 9 is what we're going to look at now, the second term here. 9 is 3 times 3. It is a perfect square. If you don't know your number perfect squares, look on that multiplication table that you've hopefully gotten by now and are using by now, and look down the diagonal. Down the diagonal, those are all your perfect squares. So now to factor this, now that we've recognized it as being the difference of squares, It factors into two binomials. The first one is the square root of the first, 2a. So we took the square root of the number and we took the square root of the variable term, 2a, plus the square root of the second, 3, times 2a minus 3. We'll look at one more example before we move on. Do this one in purple. So let's say we have x squared minus 64. X squared is a perfect square. 64 is a perfect square. It's subtraction, so this is the difference of squares. So this is going to factor into two binomials. First one is going to be the square root of the first, x, plus the square root of the second, 8. Second one is going to be x, which is the square root of the first, minus the square root of the second. So it's x plus 8 times x minus 8. Okay, so now we're going to look at perfect square trinomials. So here we go, perfect square trinomials. If something is a perfect square, what does that mean? Well, a perfect square number is a number that is the product of one number times itself. Perfect square trinomial is a binomial squared. It's the product you get when you square a binomial. So we did things when we were multiplying like x plus 3 squared. And we talked about how that's x plus 3 times x plus 3. And we went ahead and FOILed that out, and we got x squared plus, outers gave us 3x, and inners gave us 3x, so that gave us 6x when we added those together, plus 9. And that is a perfect square trinomial. Now, when you are given a perfect square trinomial like this and asked to factor it back into its binomial factors, you can do that by any method you want to factor a regular trinomial. Okay? So if it's got a leading coefficient of 1, you can just go ahead and factor it. If it's got a leading coefficient that's not 1, you can do it by grouping. There's no need to learn a formula or to learn to even recognize these as perfect squares unless you're going to be going on to pre-calculus. If you're doing 96, 140, and then 141, you're going to want to learn the formula. Okay, so let me just point out what that is here. Okay, so we're going to look at this. We're going to look at the first term. That's a perfect square. We're going to look at the last term. That's a perfect square. And now we're going to look at this middle term. If this middle term is 2 times the square root of the number here, the 9, times 3, times the square root of the first one, x, which it is, it's 6x. Then it is a perfect square trinomial. So the formula is going to look, okay? If you have a squared plus 2ab plus b squared. So if you look at something and you see, you look at a trinomial and you see that the first and the last terms in that trinomial are perfect squares, And that middle term is twice the product of their square roots. It's going to factor to a plus b times a plus b, which we can write as a plus b squared. Also, we could have, let me do this in a different color so it kind of stands out. If we had a squared minus 2ab plus b squared, that would factor to a minus b times a minus b, or a minus b squared.